Hello everybody, how are you?
My name is Giuliano Di Girolamo Neto.
Welcome back to our channel here at Civil Manifest. In this video tutorial, I'm going to explain to you how exactly you put on an elevator motor. So for that we have to take into account some aspects, some step by step here. As for example, we have here the place where this engine will be built, depending on our electrical project. We also have the information that we must put as the owner of the commercial condominium that is carrying out this construction. The destination of use that we are going to be carrying out this calculation, it is an apartment destination, it is an office, it is a trade. So all this we have to take into account. The number of elevators per floor I will consider 1 here, okay? 1. The only elevator per floor, where our consumer units are located. The population, at this moment we had to take into account the composition, which is exactly what I put above, except that it is written down here, okay? Square meter of our floor, I will consider that 600 square meters I will have there on the floor of my consumer units, 50% of the total of that area, because some areas are related to the corridor, the hall, so it does not count as apartments, so 50% is disregarded in these 600, thus totaling the result of 300 square meters. They are person per square meter. So here I have the number of people for every 7 square meters. I will have a population here, in the result of my total population of 42 people living there on that floor there, considering a single apartment, a single elevator I mean, okay? The minimum percentage to be transported in 5 minutes in an elevator is 10%, okay? Considering a total of 4 passengers for a single elevator, considering a total population of 42, right? And a floor of 600 square meters considering 300 and subtracting 50% of these 600 okay the units of our elevator group we must always consider 1 the passenger capacity that we calculate here from 5 the stops i.e. number of floors I consider here 11 the probable stops we must check this in the norm in this norm we can say that we can find this here all this calculation including this information here in the 5665 norm, okay? Here we have the route, the distance, and we must consider from the first floor of the finished ground floor or even from the basement to the top floor of the building. So I considered here the height from the finished floor to the top floor of the single floor is 3 square meters, then subtracting 30 centimeters, so I have 2.82 meters as a result. Speed of my elevator we were able to obtain this through our supplier's documents so I consider here 1 meter per second. The acceleration delay we also checked with the node through the standard through the number of passengers considered above which was 5 a passenger entry and exit here is 2.4. The opening and closing of ports that I consider here was 5.5. Usually we leave these default values as well. Calculated total times, the total route here as we had already calculated before 31. The acceleration and restart as we had put the value 3 here is 11, 4 okay. Opening and closing of the doors of 38, 50. Entrance and exit of passenger 23, 65. The sum of the total times was 106. The traffic interval also 106. The inbound and outbound traffic capacity for all elevators was 20. Consequently, as it is only a single elevator per floor for our consumer units, then we have the inbound and outbound traffic capacity for each elevator of 20 as well. In this case, we find the traffic capacity also considering the number of people, because it must be the elevator supports, which is 4 here, which according to our calculation we see that it was 5 also okay. Let's go to Panela 2 now let's calculate here this result comes out automatically as you can see all the results in blue we don't need to change we just need to change the results so here in gray are the results that we really need to add here in ours by 1000 so they give you the result here for us number of passenger traffic of 24 considered in CV of 24 okay. Convert CV into watts I have the result here 17,872, 74 watts okay. In this case for each elevator I have 12 HP so I have here 12 motors of 12 HP for a single elevator okay. Converting this into watts I have 12 motors so 8,936 watts okay. Today I get another elevator to take all that? Exactly, the less elevator the more the amount of people traffic, consequently the greater the power in horsepower. If I put 4 here for example, basically what will happen is a decrease in my traffic capacity, so each elevator will then support 5 people with traffic also of 5, so I will have here in my spreadsheet here the total number of passenger handling is from 9 the value considered in HP is 11, to convert this into 1 W I have 8,191 W elevator load to be considered as above 12 volts for 2 motors as 6. As I have a motor for my elevator of up to 12 HP, then I can consider a single motor with 11 HP for each elevator, so I will have an 11 HP motor, considering then my 4 elevators. Guys, I hope you enjoyed this video. If you liked it, give it a like, share it with your friends who have the same difficulty as you and the same curiosity in knowing how to calculate washer engines, and that's it. Until the next video.